Hi, this is Tom, and in this video, we're going to try two examples of factoring the greatest common factor. The first one is factor 12x squared y cubed minus 9xy squared plus 3x squared y. So let's begin. If you look at the problem initially, what we see is, let's just look at the number parts. So I'm going to maybe just do a little we'll just look here at the numbers. And when we look at just the numbers, you can see that there's a 3 in the third term, there's a 3 in the second term, and a 3 in the first term. So what I'm going to do is write this instead as 3 times 4x squared y cubed minus, I'm going to have a 3 times 3 xy squared plus 3 times 1 x squared y. Now, the next step, what we want to do is, let's actually take a look at the x's, because notice that here in the first term there's an x times an x. In the second term there's just a single x, and in the third term there's again an x times an x. So the most x's that I can take out of all three at once is just a single x. So let's do this. Let's write this instead. Now our greatest common factor actually has an x in it. So I'm going to write this as 3x times, well, then this becomes 4xy cubed minus 3x, and then I'm going to have a times 3y squared plus 3x times, that's going to leave me a 1xy. Okay. Now, let's do this again. And this time, let's take a look at the y's. Well, in the first term here, I have 3 y's. In the second one, I have 2. And in the third one, I have 1. So then the question is how many y's can I take from each one of them at the same time? The answer, 1. So really now my greatest common factor is going to have a 3, an x, and a y. So then the first term becomes 4xy squared minus 3xy times 3y plus, I have a 3xy, and if I look at it, then this y here is being moved out there, so I'm just left with a 1x. And now my greatest common factor is the entire 3xy. Now, if you recall, remember the distributive property, we had it as ax plus ay is the same as you take the greatest common factor, you move it outside of the parentheses, and then you record exactly what is left. So in our case, in our specific problem, the greatest common factor is 3xy. And in our general example, the greatest common factor was the a. So if we follow this model, then what we have is we can say, we write our greatest common factor, 3xy, and then we go and we write exactly what remains. Now, I do this a bit reservedly, but think about if I was to take out the 3xy from each term, then I would write exactly what remains. So in the first term, I have a 4xy squared. In the second term, I have a minus 3y. And finally, in the third term, I have a 1x. But remember, we said that 1x is usually more simply written as x. And that is factoring that polynomial. Now, let's try one more problem. The problem goes like this. It says, actually there's 2 to this. It says factor. Let's try this. How about 6? Now I'm going to write parentheses a plus x parentheses a. Now, if we're going to factor that, notice that my greatest common factor is the entire parentheses piece. So if I follow the distributive property, I would take that out. It's the a. And then I would write exactly what remains, which is 6 plus x. Now, watch what happens if we just make one simple extension. And maybe we write the problem like this. Factor 6 times, what if the a has something else with it? Like maybe a plus h. Plus x times a plus h. Well, if I want to factor that, and I really should probably have, to be more precise, I should write period, and then I should rewrite this as 6 times a plus h plus x times a plus h. Now, in this problem here, nothing's really changed except that the greatest common factor is all of this and all of this. Notice those are exactly the same, and they're being multiplied with the piece in front of them. So now the greatest common factor is the a plus h. So just like we did above, we took the whole set of parentheses, the a plus h, and we pulled them out. So if I pull out the a plus h, then I write what remains. I have a 6 plus x. And what we say is the a plus h, this is called, we say that the greatest common factor, that's f, is a binomial. And a binomial just means 2 terms. Bi for 2, like bicycle or bicycle. And that is how we make factors some more complicated examples of, we say, factoring out the greatest common factor. This is Tom. Thank you for watching.